Let's say you came across this question in your chemistry exam. How will you solve it? It is very easy. Now let's solve together. The question says 1.34 grams of hydrated sodium tetraoxosulfate 6 dot XH2O, all right, this is the hydrated compound, was heated to give an anhydrous salt weighing 0.71 grams. Now the question says the value of X in the compound above is. Now this question is extremely very easy. From the look of things, this question is from a very vital aspect in chemistry called water of crystallization calculation. Specifically talking about calculating the number of molecules of water of crystallization in an hydrated compound. So the question you ask yourself, what is an hydrated compound? Because at first they said 1.34 grams of hydrated, you can see they mentioned the compound. So this tells us that this compound in full is hydrated. Why is it hydrated? It is hydrated because of the presence of water, all right? An hydrated compound is a compound that contains water of crystallization. Please listen properly. Whereby for an anhydrous compound, it is a compound without water of crystallization. Are you there? And this is the water of crystallization, H2O. But in the course of this question, we want to determine the number of X, all right, in the water of crystallization of this hydrated compound. Now, there is a formula to do this. Please listen properly. The formula to determine the value of X, all right, to determine the number that should stand in front of the water of crystallization in an hydrated compound, it has a formula. And in the course of this lesson, I'm going to give you the formula. So whenever you see other practice questions related to this aspect, you can solve them without stress. Now, what is the formula? Here is the formula. The formula is simply X. Now, this place they wrote X can be any symbol, can be Y, can be Z, all right? In the course of this question, it was given to be X, all right? It can be anything, all right? So the formula is X is equal to MOA, whereby in the course of this question, I'm going to tell you what each of the symbols mean, into HM minus AM, all right, all divided by 18 AM. Now, let me tell you what each of the parameter means in this formula. For MOA, which you saw first, MO itself is molar mass, all right? Molar mass. And the A here means anhydrous compound, or you simply say anhydrous salt. Remember, an anhydrous compound is a compound without water of crystallization. So for MOA, it is you calculating the molar mass of this compound without water of crystallization. Now listen, they said at first the compound had 1.34 grams of the hydrated compound. So meaning that if I remove this water out of it, from here down to here is the anhydrous form of this compound. But if the water of crystallization is added, then it's going to be hydrated. I believe you're following me. So molar mass of anhydrous compound is you calculating the molar mass of this compound without the water of crystallization. And in the course of this question, I'm going to teach you how it works. So please listen properly. Whereby HM here simply means M is mass and H is hydrated. So HM simply means mass, all right, of hydrated compound. At first they said 1.34 grams of hydrated. You can see they mentioned the compound. You can see that the compound has water crystallization. So 1.34 gram, based on our formula, is HM. Are you there? Because it is the mass, all right, of the hydrated compound. Listen properly. Was heated So heat was applied to give an anhydrous salt. An anhydrous salt or an anhydrous compound is a compound without water. So from this compound, they removed water. So if they removed water from a particular compound, the mass is going to reduce. I believe you are following me. That's why they said that it was now weighing after, heating the hydrated compound to form the anhydrous compound. It was now weighing 0.71 gram. So 0.71 gram here is the mass, all right, AM, mass of anhydrous compound, all right. That's what AM means. M here is mass and A is anhydrous. I believe you are following me. All right. Whereby divided by 18 AM is still, the M here is still the same as the AM there. Are you there? Whereby this 18 is a constant value, though this formula was derived. But in the course of this lesson, I'm not teaching you how it was derived. I'm teaching you how to use it to solve questions that it is made for. Are you there? So moving further, what do we do? The next task is for us to simply calculate the molar mass of the anhydrous compound. So from this compound, let us bring the anhydrous part, and the anhydrous part is Na2SO4. I believe you understand that. An anhydrous compound is a compound without water. So this full compound, when I stop here, when I pick it from just Na2SO4, this is the anhydrous. But if water was added, it's going to be hydrated. So let's quickly calculate the molar mass of this anhydrous compound. So I believe you know how molar mass is calculated. You simply add the atomic mass of the elements involved. What are the elements involved here? They include sodium, Na, all right, sulfur, S, and oxygen, whereby these elements have their respective atomic masses. For sodium, the atomic mass is 23. For sulfur is 32. For oxygen is 16. So let's calculate the molar mass of this anhydrous compound. So here becomes 23. We have 2 of sodium, so times by 2. I believe you are following me, all right, times 2. Plus sulfur's atomic mass is 32, all right. Here becomes 32 plus oxygen atomic mass is 16, and we have 4 of it, so 16 times 4. So let's key them in the calculator to get the molar mass of what? The anhydrous compound. So when we input everything into the calculator, we are going to get 142 grams per mole. Remember, the unit of molar mass is gram per mole. I believe you are following me. So moving further, let's input all the parameters into the formula. So X becomes, what's the molar mass? Listen properly. What's the molar mass of the anhydrous compound? We've just calculated it. And it is 142. All right. Open bracket. Remember, this open bracket means times. What's HM? It's simply the mass of the hydrated compound, which is what? 1.34 minus AM, mass of the anhydrous compound, which after heating it, it weighs this value, 0.71, all right? Okay, close the bracket. All divided by 18 AM, mean 18 times AM. So 18 times AM, the AM still remains 0.71, which is the mass of the anhydrous compound. So you can see what we have done. So let's input all these values into our calculator so we get the value of X in this compound. At the end of solving this question, I'm going to give you all practice questions so you solve and provide the answer in the comment section. It is extremely very easy. So moving further, first of all, we have 142. All right, when you minus 1.37 minus 0.71, you're going to get, all right, 0.63. I believe you are following me. Divided by 18, all right, times 0.71. So what happens next? I believe you know that 142 bracket 0.63 simply means 142 times 0.63. I believe you are aware about that. So when we times 142 times 0.63, we are going to get 89.46 divided by 18 times 0.71. That is 12, all right, 0.78. And when we divide both values, we are going to get 7. So the value of X in this compound that is hydrated is 7. Are you there? So the proper way to pronounce this compound becomes sodium tetraoxo. The reason why it's tetraoxo because we have 4 oxygen, sulfate. You calculating properly the oxidation number of sulfur in this compound is going to give you 6. So a sodium tetraoxosulfate 6, since it's 7, is going to be heptahydrates. Are you there? Heptahydrates. That's how to pronounce this compound that is an hydrated salt. I believe you understand properly how this question was tackled without stress. So get ready for your own practice question. Follow through the same steps given to solve this question. Definitely you'll be able to solve the question without stress, all right? So get ready for your own practice question. So the answer to this question becomes option A. Now get ready for your own practice question. Here's your own practice question. Here at first, here that was 1.34. I'm going to change to 5 grams of an hydrated compound of barium. So in this case, I'm going to change the compound to barium, all right? Hydrated compound of what? Barium. Hydrated compound of barium, all right, was heated to give here 4.26. So you will still calculate the value of X in barium as seen here. But this time around, they've given us already the molar mass of the anhydrous salt. We are not to calculate for it, all right? So just take note, the molar mass of the anhydrous salt, is 208. So you don't need the presence of the compound here to get your molar mass. I've given you the molar mass already. So you calculate for the value of X. You know the normal way to solve. X will become, MOA into HM minus AM divided by 18AM. You understand what to do? So here, you don't need the compound in general to get your molar mass. I've given you already. So what you do for me, provide the answer in the comment section, whereby I'm going to remove all of these options. So you solve carefully and provide the answer in the comment section. If you find my video lesson helpful, make sure you click on the subscribe button to my YouTube channel and also share my lessons to your friends. Thanks for watching.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.